here we go. Moving on now to number 3. So we've been given a couple of numbers that are already written in scientific notation, a and b. We need to find the multiplication of a and b. So we can use our calculator to assist us here. We've got 4.5 times 10 to the power of -3. Now here you need to be careful. You've got two buttons on your calculator that look very similar. The negative button and the subtract button. The subtract button should only be used after a number, immediately coming after a number, to demonstrate that we are taking that number away from the number in front of the sign. Here we want to use a -3 because it's not a subtraction, it's just a negative number. And now if you have the new operating system, you'll see that the cursor is kind of stuck wanting to go to the right. If I keep typing, it will go into the exponent. So press the right cursor key, and now you've exited the exponent and you're ready to multiply by the second number, b. And same thing now, quicker, 6.2 times 10 to the power of negative, remember the negative button, 4. And calculator gives it to me in this form. You're not allowed to write down this form. IB will not accept this form. You need to write it down in proper scientific notation. 2.79 times 10 to the power of, and here our exponent is -6. Do not write down a capital E in your answer on an IB question, or you will lose a mark. Part B. Now then, we might have to do a little bit of work on this. Before we multiply by 2, we're going to need to add the two values, a and b. But I can actually do all of this into my calculator at the same time, so I can say 2 times, open brackets, and I'll show you, yeah, I wish I could call up the number from a previous entry. This is not the right time to do that, but sometime in the future I'll show you a neat little command on the calculator. And part B is 6.2 times 10 to the power of -4. Now let's exit the exponent if you have the new operating system. If you don't, please mention this to me in class, and I've got a cable that I can circulate so people can start transferring the new operating system between their calculators. You'd need the TI-84 plus to do this. And we'll close the parentheses, and there we go. We got 0.01024. Okay. Oh, you'll see that in part A, I've already, as it turns out, done what they asked. I should have read ahead. In fact, that's an important skill, isn't it? Is reading an entire question before we then answer it. I could have missed this if I thought I was finished and continued. So read the whole question. Give your answers in scientific notation. Turns out that I did this in part A. So maybe I was a bit lucky that I left it in the form they were asking for. But I haven't yet done this in part B. To write this in scientific notation, we'll count through the number until we reach our first non-zero number, which is a 1, and that's where the decimal point's going to go. How many times did we move the decimal point? It was here, it ended up here. That's 2 times. And is it a positive or a -2? We are dealing here with a very small number, and small numbers have negative exponents in scientific notation. Right, number 4. Oh, whoops, I need to check the mark scheme, don't I? So, let's see how IB awarded the marks here. So yeah, in scientific notation, there's an implied method mark. If you ever see a mark scheme, usually the parentheses refer to something implied, but IB will probably just simply give you, if it's in brackets, IB will just give you full credit if you have the correct final answer, as we do, and as we do. So, easy enough. Interesting that they would have also accepted an answer rounded to 3 significant figures. You remember one of the things we talked about in class is that every answer should either be given exactly or to 3 significant figures, unless the question specifies otherwise. Number 4. Alright, we've been given a rather complex formula here, and we're supposed to use our calculator value of pi. Let's calculate the volume for these three particular values of r, capital H, and little h. So let's write down the substitution first. I'm going to write this down by hand. Some of you might be able to skip this step, but I'm going to keep this as a pi as a reminder that I want to use the exact value of pi that the calculator uses. This pi is multiplying r squared. My r is 4.26 in this question, squared. I then need to multiply by, because when there's no symbol in between two things, we know that's in a multiplication. We need to multiply by capital H minus little h. And now is a great time to use the calculator to enter this amount. So to get the value, the exact value of pi, we'll say second and then the hat. And that calls up a little pi symbol. It will be the exact value. Times 4.26 squared times, open brackets, 21.58 minus 14.35, close brackets, enter. And it wants the full calculator display. Here we go. 412.1994123. Part B. Give your answer to two decimal places. Two decimal places. Here's the decimal. These are the first two places after the decimal. That will be our cutoff. So we have 412 point. Now let's see what happens. The number after the cutoff is a 9. Well, that must mean that this 9 goes to the next number. Well, you can't bring a 9 to a 10 and fit that into a single place value. So we'll look at the 19, and just like on a car odometer, that will roll over to a 20. And we need to include the 0 at the end, because you need to demonstrate that you have given your answer to two decimal places. Part C, give your answer to two significant figures. So our two significant figures, well, I should use my original number, shouldn't I? Here's my first significant figure, because it's my first non-zero digit as I count from left to right. And then, of course, the one immediately afterwards, no matter what it is, has to be the second significant figure. And so that's going to be my cutoff. I'm not going to draw my cutoff in this situation because I don't want to obscure my answer to part A. But you can imagine my cutoff is coming immediately after that 1. And because the number after that cutoff is smaller than 5, we do not change the 1, and we put in zeros everywhere afterwards. Now I need to put in the 0 before the decimal point, otherwise I've completely changed the value to 41. If I want to show that it's 410, that kind of magnitude of a number, I need the 0. But now I don't need to include any more zeros, because they're not going to change my concept, my understanding of the size of the number. And so there's two significant figures, 1, 2, and everything afterwards is 0. Part D, we need to write our answer to part C in the form scientific notation. And so we know that scientific notation puts in a decimal point immediately after the first non-zero number. So 4.10 didn't ask us to do any additional rounding. And we need to multiply by 10 to the power of, well, here we've moved the decimal 2 times. Is it a positive 2 or a negative 2? Because the number that we're dealing with is reasonably large, it is a positive integer. And the mark scheme assigns marks in the following manner for number 4. So it would have been a method mark for demonstrating your substitution, although I rather suspect that if you didn't show this, you could have still got full marks if you had the correct answer. The reason the 1, 2, and the 3 are in parentheses is because maybe some older versions of calculators that are allowed for the exam would have only gone as far as the 1994. But of course our nice TI-84 calculators will show the whole display. And so that's a 2-mark question. Part B, C, and D are also each worth 2 marks. Part B, that's to 2 decimal places. Part C, to 3 significant figures. And you'll notice that these on the mark scheme is given as A2s. An A2 mark means that it cannot be split between 2 different things. It's simply given 2 marks, bang, straight off. and if you got the wrong answer, bang, you lost those two answer marks straight off. So no partial credit on these two questions. And in part D, we've written the answer to part C in scientific notation. And as I mentioned earlier on, here they've actually given an explicit note. We give 1 mark for the 4.10, and we give 1 mark for the 10 squared.